My name is Duncan and I will be hosting everybody today. With me I have Tabang and Dani, our national organizer. We'll be going through quite a few things within this very short presentation. I hope that you are ready. I hope that you will enjoy it, and that if you have any questions, you are welcome to type them in the chat at any point, and we will get to the Q&A right at the end of our presentation. So without further ado, I know everybody's been waiting quite a while. Over to you, Dani.
Thanks very much, Dunks. Greetings, everybody. Duncan's already welcomed you, but certainly happy to be sharing all the information for World Robot Olympiad for 2024. And we had a lot of people register, and a good feedback from last year. So it's really good to be doing the webinars, number one. Today, obviously, an introduction. And I'll be doing talking about future innovators, Robo sports, and future engineers. Before we do that, I just thought I'd share with you a lovely picture. And if you've been on Facebook, you've seen it. And that's our contingent of 61 people that went to Panama last year. We had 7 teams, and we had great success. Obviously, very tough competition, but an incredible experience for everybody there and coming back. And then Philo, our mascot, obviously showing off the beautiful photograph. Right, so let's move on to Future Innovators. Future Innovators is the old open category, which is project-based. Do a presentation. So in the red block, basically Future Innovators is work on a project to design and build a robot. And there's lots of research and planning and design involved. The age groups here are 8 to 12 for elementary, 11 to 15 for junior, and 14 to 19 for senior. So typically there is a theme of Earth Allies, which is the overall theme for World Robot Olympiad in Turkey this year. But within that, for Future Innovators, there is a theme that needs to be researched and approached, and that's what you've got to design your project and robotic solution around. So there's a lot of reading to do. I'm not going to read it all. So from a theme perspective, I want you to focus on the words Earth, destructive natural events, safe from natural dangers and disasters, and live in harmony with nature. Okay, which all of us are starting to do, hopefully at home, school, and in our fun time. So within that, you've got 2 options. You can combine the options. They don't have to be separate. One is sustainable future, which is keeping our Earth livable for the coming generations, which is critical. We can't just think about our lives on this planet. We've got to think about those people like us who would like to thank people like us who've done a lot for it. Okay, I hope you followed that. Option 2, the force of nature. So typically what happens is humans have settled in areas that offer favorable opportunities, but prone to natural disasters. I'm always amazed to watch programs on television where the local people move back into areas where a volcano has exploded, for example, and then rework that because they're safe again for another 10 to 15 years. So we've got to discover ways to coexist, and typically because we're trying to keep human beings safe is how we can reuse robots and robotic solutions to deal with that for us. Future Innovators, 2 to 3 participants in a team. You can see in the picture, this is international competition where you have a cubicle of 2 meters by 2 meters by 2 meters, and you have to display and present your posters and your project, your solution within that time. There's no restriction on robotic platforms, so you can use any robot type or programming that you want to, and you can use, things that wow and models and et cetera, to eventually pitch exactly what you're trying to solve through the topic that you've chosen. Basically, a 10-minute presentation to the judges. So you would present your pitch to 2 to 3 your judges 2 to 3 times. They would all score you independently. But basically, within that 10-minute time, you've got a 5-minute presentation where you actually, each person in the team does a does a part of the presentation, explains who they are, why they thought about this problem, and how it's going to perhaps help humankind going forward. And then there's 5 minutes for the questions from the judges. So the judges would have listened in, they would have read the report beforehand, etc., and watched the video if you're international, and then they would have prepared questions for you to see how well you know your project solution. And secondly, is how much of the coding and the mechanical stuff you actually know about. So they will try and ask difficult questions, because typically here we want to make sure that you've done the work and you haven't used some aeronautical engineer to do the work for you. To do your research and get ideas, you can go anywhere and ask anybody. Judges score the team on a rubric with 200 points. And typically those main topics over there are project innovation, research report, robotic solution, presentation, and team spirit. And it's an absolute, we don't have a lot of teams in South Africa participate, but it's been our most successful with the second in the world about 8 years ago in the senior category. Right, so let's move on to the next category, which is future engineers, which is the advanced age group. And as you can see in the blue block, the age is 14 to 19 years. And we will repeat this, but every age that you see typically on these slides is in the year of the competition. So if you're 19 now and turning 20 in July holidays, well, unfortunately, you fall out of the required age group. Future engineers in general, the idea here is advanced robotics following current research trends. And typically throughout the world at the moment, and for a while already, self-driving cars is very, very prominent. So this particular challenge is around that. A robotic vehicle needs to drive autonomously on a park and drive course mat that randomly changes for each competition round, which you'll see in the next slide. Teams focus on all parts of the engineering process, documentation, processes, make a public GitHub repository where engineers can actually research what they've done. And then every year, because this has been going for 2 years now, and we've got another 2 years, this year and next year, that we'll have future engineers, but every year there's a slight change. The whole challenge will change every 4 or 5 years. So typically in end of next year, so for 2025, future engineers will change from self-driving cars to some other current research robotics topic that is prominent at the time. On the next slide, here's a picture of the 3 meters by 3 meters mat that you have to drive around. And first of all, 2 to 3 participants, as in all teams for proper WRO. No restriction on robotics platform. So here you can leapfrog, the basics and go to stuff that you're very happy with and easy to use for you. The one restriction here is that you cannot use an omnidirectional wheel like you've used, for example, in your robots in other competitions, other WRO competitions, Mission, Explorer, etc., etc. The reason being is you need to be building a driving robot like your car, where both wheels turn in the direction that you need to go. And it's not just a swing around. The rules, the vehicle must complete. So first of all, there are 2 parts to the challenge. The open challenge, which the vehicle must complete 3 laps on the track, and the start areas are random. And then random placements of the inside track walls. So at the moment, you'll see there's some pillars in here. So in round 1, can you see this square? Okay. That may move around, and sometimes it's a rectangle, so it's shifted to a different place to make sure that your robot is actually able to avoid it, even though it's been moved to a different area. And you need to complete 3 rounds of that and finish where you started. The second part of the challenge, which is the obstacle challenge, and as you can see, there are little pillars on this, where you've got green and red pillars that have been placed, and those are placed randomly per round of the competition. So you might have 1 or 2 opportunities. And in the past, the vehicle must complete 3 laps again. Okay, but typically, if the vehicle sees a red pillar, it needs to pass on the right-hand side, or a green pillar, it needs to pass on the left-hand side. And that instruction might actually change from round to round. This year, the competition has changed so that, in fact, if the last pillar is green, you continue and you complete your 3rd lap with no difference. If the last pillar is red, you have to turn around and complete the 3rd lap in the opposite direction. You'll obviously have a finish point for it. After completing 3 rounds, the vehicle has to find the parking lot. So as you can see, there's another area which has been included here for round for the obstacle challenge, which is the second part of the competition. Then you have to do parallel parking into that area. Incredible. We did see it at the international competition. It's really, really incredible to see this happening. And we have got lots of teams starting out in this category, and we hope to show those at our provincial competitions. Right, now let's talk Robo Sports. So it says Robo Sports here, okay, and the age group there is slightly different. So slightly younger can be incorporated, 11 to 19 years old. And it's teams compete with 2 robots in an exciting game. So in the past, some of you will know that it was Robo Soccer or WRO Football, where we had 2 robots playing football against each other. And then this has been around now for 2 years. This is the 3rd year and will be the last year next year. So this has been doubles tennis, okay? And that will change at the end of next year. Again, they've made it slightly, they've improved it slightly. First of all, I think what's not on here is that you don't know is that, in fact, they've included Arduino into this category as well. So you can use Arduino. Each team has 2 robots. The robots have to be fully autonomous. Teams play 3 matches against each other. A match is 2 minutes long. And then the format of the draw depends on the number of teams. So whether you actually play in a round robin, pre-qualifying rounds of quarterfinals, etc., and which then become knockouts. The big change this year is that for the last 2 years, they've just been using the orange balls. Now you'll see it on the next slide as well, but you can see there are 4 orange ping pong balls on each side of the table. Those are also placed randomly to start when you start your match. And effectively what you've got to do is get as many of those ping pong balls from your side of the tennis court onto the other side. And when the match finishes, the team with the least amount of balls on their side actually wins that particular match. What they've done this year, the orange ball obviously was 1 point, okay, and then the purple is -2 points. So basically now there's another aspect involved here. So typically, even if you've got no balls on your side, you can't end on a -2 because you've got no balls. But if you've got some on the other side, then obviously the other team is the one that has most balls on their side. Right, I'll just go forward one more slide. You'll see the table, the proper table, and you see you have ramps here. So effectively what happens is normally these robots have the pixie cams on them, which can recognize the color of the balls. And the ramps, for example, the center line is the net. So you can actually design a robot that actually throws something over the net, or you can design something that drives up onto the ramp and shoves the balls over the net, but your robot is not allowed to touch the red area. And if, for example, your robot does go over the top, then the match will stop, and because you have ended the game, they stop that particular match. Team of 2 to 3 participants again. Only 1 controller per robot. Only 1 battery pack is allowed per robot. And then typically, from a pixie cam perspective, is you're not allowed to have orange and purple parts on your robot because the pixie cams on the other side may pick those up and get confused. And in fact, that's even from a clothing perspective. So judges will make sure that those colors are not prominent around the table when the match is happening. And then as far as the rules are concerned, have a look over here. I spoke about the Arduino controllers, but there are all EV3, Spike Prime, etc., Robot Inventor even, and officially, the only official Arduino controllers are used. And then the rest of the rules, which are quite intricate, you have to refer to the document. And I think that's it from my side. Yes, so you've had that. I'm going to pass you on to Duncan, who's going to talk about Robo Mission. Thanks, Duncan.
Thank you, Donnie, for that. The first thing is, what is Robo Mission all about? It is a table-based competition, just the same as Robo Sports, almost the same table, except Robo Sports is slightly higher. There is an international final for the Robo Mission category. It is the largest competition of all the WRO categories, and there are 3 age groups within our Robo Mission. In order to participate in the Robo Mission category, you will need to purchase a PVC roll-up mat, the one that matches the age groups that you will be doing. Because it's 3 different competitions, there are 3 different roll-up mats. It is restricted completely to Lego elements. You may only use Lego elements. No other elements are allowed to be used. You are only allowed to use ones branded as Lego. So even the rubber bands that you use must come from Lego. It's open to any programming language you like. So whatever you're using, whether it be Mindstorms itself, Java or Python, you are welcome to use it in the RoboMission category. It uses the brick sets 45811 and 45819. You need both of these brick sets, and it's 2 of these boxes per table. So 1 45811, 1 45819 to complete your table elements. The height of the tables in South Africa, and the one that we use, is 70 millimeters. So our table height is slightly higher than the international standard. And the reason for that is because the international standard is set at a minimum of 50 millimeters, and we are not sure what will be at the international. So making it a bit higher will help you if the table is a bit higher at the international final. If you would like to order any of these sets, please email info@handsontech.co.za and place a brick set order with the guys there. Next up, we have our age groups. So for the elementary category, it is ages 8 to 12, junior 11 to 15, and senior 14 to 19 years. As Donnie had explained, this is the age that you are turning in the year of the competition. So if you are going to be turning 19 this year, you can still participate in any of the WRO categories. If you are turning 20 this year, you may also participate, but as a judge, not as a participant. Rules for RoboMission: teams arrive with a pre-built robot. That means you come to the competition with your robot completely built, sensors attached, cables plugged in, and battery fully charged. You do not share your robot, your program, or a programming device with any other competitor, including teams from the same school or same club that you are working with. Teams must practice and score only on their assigned game mats. So each team will be assigned a mat. They must practice on that mat and score on that mat. Teams have 3 scoring opportunities within the RoboMission. These are 3 separate opportunities that you will have a quarantine round for, and then a scoring round. Randomization is conducted by the head judges in the quarantine, which is before each scoring attempt. All of the robots must be in quarantine before the timer hits 0. If robots are late, penalties may be applied to the teams. These can range from teams receiving 20% of the score, or from not being allowed to run in that particular scoring run. If your robot fails a quarantine check, it's too big, you have 3 minutes in order to make the change to the robot. So you take your robot back to your table with the judge, they time you. When your 3 minutes is up, your robot gets tested again. If it doesn't meet the size requirement, your robot will not be allowed to participate in that scoring round. A very important rule: your robot in the start area must fit completely inside of the white area around in the start. So everything must fit inside of that area. This includes the cables, and if you are in elementary or junior, this includes the water block or the cable that you are putting on your robot to start. For our elementary age group, this is your challenge. Your robot starts in the starting area over here with the blue block placed on your robot. These yellow blocks need to be taken to what's called the compost area, the brown area down here. The red ones need to be taken up to the market area. These green ones need to be left alone. Now, this area here will be randomized. We don't know what elements will be placed in these areas. There will be green and there will be black. We don't know the position of these elements. They are random. If it's green, it must stay where it is. If the block is black, you must move it outside of this dark green rectangle. We then have these elements sitting on the yellow blocks and these 2 elements up here. These are also randomized. Now, these ones are the same as down here. They will be red and yellow. So pretty much everything from this side of the mat outside of the start area is randomized. The only thing we know is the starting position of these 4 elements here. You are guaranteed to know those 4 elements. Taking a closer look, we can see that our blocks on these sides here are enclosed in a little cage. Your robot will need to lift the cage or get the block out of the top somehow without moving the cage. That cage has a hinge, it lifts up and can be left upright. The water block tower contains 2 extra water blocks which need to be taken from the water block and placed in front of one of these green pieces. If Your robot is not able to do that. If you are new to this competition, that is the most difficult thing to attempt in this elementary challenge. So please take your time with it and work as best as you can. Moving now to our junior age group. Our junior age group, the robot starts in the mission area over here with this yellow cable on the robot. That cable needs to be taken and placed inside of this yellow area down on the far right of the mat. The area down the bottom here will be a mixture, a randomized set of elements. We will have 2 duck elements and 4 plant elements. What needs to happen is your robot needs to take 1 duck element and 2 plant elements and put them into these dark green areas. There are a total of 6 elements, which means 3 into the bottom over here and 3 into the top. We then have these yellow panels on the side. They need to go to each of these red buildings on my diagram. They need to be completely inside of this dark gray area. And to get extra points, if you can place one of them inside of the house, inside of a green area, you will get more points. So looking a bit more in depth, there are our elements. So you can see we've got the large house with the door. The door needs to be closed in order to score your final points. And these little elements over here, again, this is how it should be. However, note the base color. You need 2 black base colors to be placed into 1 dark green area and 1 blue to be placed into a dark green area in order to score your full points. We then have 2 bicycles placed right up the top that need to just be pushed into this dark yellowish area there. They need to just sit in that area. If they've fallen down, that's completely all right. Moving on to senior, our most difficult category. Senior has 2 randomized start positions. We have position A and position B. Depending on where your robot starts, will depend on what elements are placed on the side. If you start in A, there will be a green or a blue element placed in this position A. If you start in B, they will be placed in B over here. So everywhere that you see these green blocks, these will be the randomized blue and green elements. We don't know where they will be other than, or what color they'll be other than they might be blue or green. Your robot needs to move and knock these 2 pipe elements so that the bar falls down onto the element. There are 2, one on either side of the mat. We have these yellow elements in the middle there. These rubble elements need to be taken and placed on the Earth Allies area. The closer you get to the logo, the more precise your robot will be. That's a tip for you guys. The big challenge. We have yellow, red, green, and blue squares in the center of the mat. Your robot will need to stack those elements, all 4 on top of each other. If you get all 4 in a tower, you score the maximum amount of points. It is very tricky, so please, this will be based on your robot design. So try and come up with a very creative design and a simple design to try and attempt this challenge. Next up, we have a look at some of the Robo mission scoring. So in order to score, your teams wait for the judge to give you the go-ahead during the scoring round. The team must touch the robot when the robot has finished to indicate that they are complete. Their robot will not do anything else. Please get your teams to do this. This is the best way to have the judge stop the timer. The rules state that if a team shouts stop, the judge will stop the time when the robot stops moving, which means if your team shouts stop and they start celebrating and the robot's driving all over the map, the judge is still standing timing. You're losing your time. You have a maximum of 2 minutes to do this challenge. So please get your teams to physically stop and end the program on their robot and leave the robot on the table. Teams must sign a score sheet if they agree with the score that's been given. If they do not agree with the score, so the score is incorrect, they must tell their table judge, who will then call the head judge to make a final decision or a ruling as to what will happen. The head judge's decision is final. Only once a score sheet has been signed, the judges will ask a team to pick up the robot and move the elements back into position. This is due to the reason that if the head judge is called to the table, they need to see what the table looked like in order to make a decision for the scoring. To determine a winner in the Robo mission category, It is by the highest score in the quickest amount of time. This is the highest score that's taken of the 3 scoring attempts with its matching time. You have a maximum run time of 2 minutes. So if your robot can do something in 10 seconds, then you will be able to do very well. So to give you an example, we have Team A that scored 100 points in 1 minute and 5 seconds. Team B has scored 100 points in 1 minute. Team B would be declared the winner, even though they have the same score, because Team B did it a lot faster. There are some updates within Robo Mission. No high technique color sensors are allowed to be used. So if you've got your high technique color sensors, hide them away. Don't let your teams touch them. There is no finishing area for the robot. So the robots can just stop wherever they are on the mat. So please get your teams to touch the robot to make sure that they indicate to the judge to stop timing. Next up, we have the Explorer category with Tabang. Tabang, you may take control.
Good afternoon, everyone. Hope you guys are doing well. So yes, to get right into it, I will actually just take you through the Explorer category. So first slide, what is the Explorer category? So the Explorer is a South African created, a South African based competition that is aimed or targeted at teams or learners that are new to robotics and are new to the WRO competition. So this competition doesn't have an international final to it. It only has your provincial level and national level. So you'll start with your provincials and the national level will be the end. In the Explorer category, we do have 2 age groups, which are your Explorer Prime and Explorer Light. Sorry, Explorer Light and Explorer Prime. So Explorer Light is ages 8 to 12, and Explorer Prime is ages 11 to 16. We will actually just go through the 2 categories later on, but moving on to the next slide, just the specs of the Explorer and what you will need. So the Explorer uses the Robo Mission Elementary game mat, as you can see there, and it also uses the brick set 45811. So for the Explorer, you won't need the 45819 like the Robo Mission, but you'll actually just need the 45811. And again, likewise, if you are looking to order the mat or the brick set, you can just email info@handsontech, or else you can just go on to www.handsontech.co.za and you can just place an order online. Explorer is open to any programming language, just due to some of the software is being discontinued or retired. So we have then just opened it to any programming language, but it is still exclusive to Lego Education controllers. So you do have your NXT, your EV3, Spike Prime, and I think, correct me if I'm wrong, Mr. Duncan, but it's also open to the Robot Inventor. So you are limited to... Perfect, thank you. So you are limited to 1 sensor of each type, so you can't have 2 color sensors in your robot. You can only have 1, likewise with your ultrasonic touch and your gyroscopic sensor. So those who are using Spike Prime, they already have a built-in gyroscopic sensor, so they don't need to worry about that. And now moving on to the 2 age groups. So you do again have your Explorer Lite and your Explorer Prime. So Explorer Lite ages 8 to 12, and this here uses a partial scoring system. As you can see with the example there, sorry, I'll just grab my laser. There we go. The brick there is not completely inside the area, but is partially in. Explorer Lite, they do then get the full 25 points there. If you move on to your Explorer Prime, which is for ages 11 to 16, a completely in scoring system works unless stated otherwise. So as you can see again with the example, similar to the one illustrated in Explorer Lite, the element is not completely in, so in Prime they would get 0 points for that one. And a note for coaches, teams can only enter or compete in Explorer once per age group. So if you do have a team competing in a Explorer Lite this year, they unfortunately can't compete in Explorer Lite next year. They will either move up to Explorer Prime if the age allows, or else they will then just register and enter into an official WRO category. For Explorer Prime, children who are doing that this year, they can't enter into Prime again, and they can't go down to light, so they'll then need to move on to your official WRO category. Then next page, again, similar to Robo mission, the start area, your robot needs to start completely inside the white area, and it must not overlap, as you can see with that example there, over the borders. It can't do that. It needs to start within the white area. With Explorer, we don't have quarantine, so it will be up to the judges to determine whether the robot is inside the area or not. Next slide, going on to the Explorer challenge now, the competition mat. So I'll first take you through the basic ones, and then we'll take you through the daisies and the randomization. So you do have your start area there. So again, it needs to start within the start area. You do have your black compost boxes. Those are not to be moved. If those remain where they are, teams will get points. Likewise, the green tomatoes, if they stay where they are, teams will get points for that. You do have 2 water blocks. These water blocks need to be collected and placed in 2 of the 3 white house, no, not a white house, but yeah, a greenhouse, sorry, in 2 of the greenhouse areas there. If a child puts 2 water blocks in 1 greenhouse area, we will only count for 1. So only 1 per greenhouse. And then from there, you do have your yellow daisies, and these are the starting positions for the 3 daisies. So all they need to do here is just make sure they push the daisies out and make sure that they are touching or are on the green grass, and they need to be completely on the green grass. And then at the bottom here in this section, for the first time in Explorer, there will be a randomization. So the randomization will take place at the start of the competition, and it will remain throughout the whole day or throughout the whole challenge. So with Explorer Lite, only this section here will be randomized. So the red tomato might start in the area closer to the start area. It might start in the middle, or it might be closer to the swimming pool. So we'll only just do the randomization when we actually are at the competition. And then just to elaborate more on the daisies, there we go. So only 1 daisy needs to be inside either the peach circle or inside the orange rectangle. So if the daisy is pushed and is touching the peach circle, the team will score 20 points. If they manage to push it and it's touching the orange rectangle, they will then score 40 points. Or else, if the daisy is just pushed and it is on the green grass, they'll just score the 10 points. And then likewise with the red tomato, if it is partially in, they will score full points, as Explorer Lite uses a partial scoring system. And I'd just like you guys to also just take note of where the diver starts as well. So all they need to do with the diver is make sure they push him into the swimming pool. And there is a little note there, so changes that we've made are 40% minimum power. So that's what we are recommending and are asking coaches to run with. So teams need to make sure they are set to a minimum of 40, just so they give other teams enough time to practice. And a team can only get a maximum of 3 minutes on the table. If they take longer than that, the judge will then just ask the team to either speed it up or to actually just give another team a chance to run. The Explorer Prime competition, likewise, similar setup. The only addition to it is the cutting box there, of which the 1 daisy will need to go into if teams do attempt that. But yeah, similar again, you have your compost boxes and you do have your water blocks. With the Prime, you will actually, well, both sections at the bottom here will get randomized. So section A will be randomized and section B will be randomized. So you will get one red, one green, and one empty space. So that there will again take place before the start of the competition. And just going to the yellow daisy and the cutting box, similar to light, if they make it into the peach circle, they will get the 20 points. If they push it into the orange rectangle, they will get 40. But if they do manage to put it inside the cutting block, they'll then score 60 points for that. And then coming to the red tomato, again, completely in scoring works unless stated otherwise on the scoring sheet. So like we have the red tomato there, it's not completely in, it's partially in. Teams would unfortunately score 0 points for this. And as I move on now to the Explorer's scoring. So again, light and prime, partially in versus completely in. And then teams must score and practice on their assigned tables. So teams can't go onto another table. If they are looking to practice or score, and the team in front of them is taking time, they should just actually tell the judge at that table, that the team is taking time. Could they actually ask them to speed it up? But they can't move from their assigned table. They must stay there. Teams do have then 4 scoring opportunities, which I'm sure you might have seen on your Explorer rules. So when teams are looking to score, they can actually just go up to the judge, ask the judge or tell the judge, would like to score this round. They run their robot, and based on how it actually performs, they can go, yes, you can actually continue with the scoring. The judge will score them, or if the team is not happy with that, they can actually just tell the judge, please don't score that. We'll come back afterwards. So they can do that. And then another one is teams must log at least 1 score in the first hour. So that there is pretty straightforward. Teams must just make sure that they actually log in a score within the first hour. If they don't do that, next time they come to the table, the judge will then score them there. And then the next point, team scores are recorded if the points value is higher than the previous logged score. So if a team comes and their first score, for example, they've scored 40 points, and for scoring round 2, they now come and score 30 points, the judge won't write that down. They can only score higher than the first score. So if they score 40, that's their score, and if they come back and score 30, we won't take that, but we will take a 50 or 60, depending on how high it is. And then determining a winner, highest score in the quickest time, but it is different to Robo mission. So again, the teams have this 4 scoring opportunities, and out of those 4 attempts, we will actually just take the highest score there. And again, time is based on the time the team or the score was written. So we do have a small example there. We have team A and team B. So they do have the exact same points, but again, team B logged their score at 2 o'clock and team A logged it at 2:05. So again, in ranking, team B would then be the first ranked team just because they did manage to score it earlier. Just small updates to the Explorer. Teams are not allowed to show up with my blocks saved. All they need to show up with at the competition is a blank coding screen, and they will actually just code from scratch when they get there. If they do have programs saved before the competition, the judges will just ask them to just delete those, and they'll just need to start afresh. Again, regarding the programming language, any programming language is allowed, and the speed as well. We do recommend that they actually use a minimum of 40% just to try speed things up and actually just try make it fair across all teams that they actually get the same amount of practice time.
Thank you, Tabang, and thank you for explaining Explorer. It's a very difficult thing to come in and take over an entire category like you have done. Thank you very much for everything that you're doing there. So some rules for coaches and spectators. There is no communication with any of the teams. This is for pretty much all WRO events, except for maybe future innovators, because the coach there can come up and talk to them, just not while the team is being judged. So communication refers to assisting a team with programming or building, using hand signals, flashcards, a mobile or digital device, otherwise verbally by whispering or shouting. Waving hello and words or signs of encouragement are allowed, and we encourage it. These are not seen as a team being or cheating because someone is giving them a wave. So please, if you see that at the competition, wave at your team as well and let them know that they're doing well. The kids need your encouragement because the pressure that they'll be under at these competitions is immense, and sometimes their robot is not doing well. And they need encouragement not only from their parents, but from everybody around them. That includes any other coaches, teams in the area. We want to encourage as many teams as possible. Penalties will be included or put onto teams if coaches and spectators and teams are caught talking with each other and judges have verified that there is an actual issue. Penalties may be score deductions or, in severe cases, complete disqualification. Some more rules. If you must communicate, communication must happen through the head judges and official WRO personnel, not through the table judges. The judges are on the tables looking after your teams. They need to look after the guys that are there, because if you take a minute away from them, you're taking a minute away from all of the teams at the table. So please, if you want to communicate with your teams or you have issues, you need to flag down the head judge or a WRO official, and they will be able to answer questions. Food and drink is not allowed on any of the competition tables. This is because we don't want a computer to become covered in a sticky substance from some cool drink that's fallen down. We don't want anything bad to happen to a robot or to get jammed up by tomato sauce on somebody's fingers. There are going to be demarcated tables for food and drink, so please have a look out for those. If you have something for your team to eat and drink, it must be placed on that table. You can then wave at them and point at the table, and then they will know where to go to get something for themselves. Now for the section that everybody has been waiting for, the official Q&A. This is our first one for the year. With this, you can always send questions to wro@handsontech.co.za. We will always answer your questions there. So please, if you have any questions, you are welcome to send them to wro@handsontech. So our very first question, any tips for beginners with no previous competition experience? My best tip for anybody is to approach it simply. Don't try to do everything all at once. Just have fun on your first competition day. What I always told my teams when I was coaching is your first competition, you are going in as spies. I want you to see how the other teams do and just find out how and why they work so well. Focus on having fun for your first competition. Don't focus on winning. Don't focus on trying to be the best. Just enjoy yourself. If your robot is not working, what I tell all my teams is try and destroy as many elements on the table. That's always fun, and sometimes that could lead you to get through to nationals just by mistake. Can we enter the junior Robo mission competition if we're not affiliated to a school or a club? The answer is yes. We allow private entries into WRO. So if you are a parent or a guardian and you've got someone at home, they need to find a team member, teams of 3, and you can enter them as a private individual. You can come up with your own name if you like, and you can enter your team under that name. You do not need to be associated with any school or club in order to enter a WRO competition. On that as well, we have what we call our in-house competition. This is open to anybody and everybody of any age group. It is a competition that happens in October. There will be a mat that will be based on the elementary mat, a competition all around that. And you complete this during the competition week and submit scores to the WRO SA website. You will then receive a certificate for competing in-house. So please, if it's your first time, come to a competition, do your best, and then we've got another one for you with the in-house competition. What does it mean to be in quarantine? So to be in quarantine before the timer hits 0, there are tables that are set out by the team competition tables. Teams must place their robots on their assigned point before the official timer runs out. Your teammate have 1 hour to run, and then They will have to place their robot into the quarantine zone before the official timer on the screen runs out. Are there any fees for participation in WRO? Yes. Teams pay 300 Rand per team member. That means that if you've got a team of 2, you will be paying 600 Rand, and a team of 3 will be 900 Rand. It is based on per participant, not per team. If you've registered your team, you will receive an invoice and an email detailing what is needed, which categories you're in, which events you've registered in, and where you need to go. Dates for all of our events are on the website, so please, if you want to see the dates, they are all on the website under dates. There are also the venues as well as what categories will be at what venues. We code with spike robots. Our learners just cannot follow the line. We have tried some techniques, but not coming right. Advice for following the line, please. If you want to follow a line, there's a couple of techniques. The best thing to do, I have found, is to jump onto YouTube and type in line following. There you will find a very useful source which will be able to assist you. Otherwise, you are welcome to email handsontech, info@handsontech.co.za, and someone at Hands on Tech will be able to assist you with learning some line following. They also offer training for teachers interested in the Spike and the EV3 platform. For Explorer Prime competition, does any programming language mean that we can use blocks coding instead of Python? Yes, it means that anything is allowed to be used, whatever you like. If you develop your own programming language, well done. You can use that within the Explorer category, as well as most other WRO official categories. You cannot enter a team of 4. Teams are limited to 2 or 3 members per team. A team of 1 will not be allowed to participate. They need to find a friend in order to jump into the competition. This is the official rule from the international competition. So if you have a team of 4, congratulations, you've got 2 teams of 2. Best possible one to enter if it's your first time is the Explorer category. The reason is because this is the category that we created ourselves for beginners. It's an easier learning curve. It has the same kind of things as Robo mission teams would experience, in that waiting for line, judging, different table environments, a whole range of different things. It's also a lot easier to score there depending on your team, because your team will be nervous. So please enter into the Explorer categories. That is really the easiest one to go for, especially if you are brand new. And remember, you can enter Explorer and the in-house as well. So you've got 2 learning opportunities. Keep it small if you're going to start. Make sure that you give all of the teams the time that they deserve. And my biggest tip is let them do everything themselves. You cannot program for them on the day. How it happens is your teams will arrive, they'll move and sit in their competition area, and you will sit on the sideline. That's all you can do. It's up to them. So if they don't know how to program something because you've done all of the work, you're going to let them down and they are going to fail, especially if there is going to be randomization or special rules on the day. So please let the children fail by themselves, succeed by themselves, and learn something along the way. If you would like a more detailed list of setting up a club or some help with it, you are welcome to send us an email and we can give you some great advice. I hope that's answered your question. You can send a question to wro@handsontech.co.za and we'll be able to assist you with more information, because we need to get a little bit of information about what you're using, where you're based, and what kind of products you want to go and how far into WRO you want to go. In-house, we've created as a way for teams to keep doing robotics when the competition has ended. Because you are doing it by yourself and just entering scores, it's not really a competition, it's a challenge. We want to make it as cheap as possible. So in order for you to register, you will need to register your school. And under your school registration, you can enter as many teams as you like. So You can enter hundreds of teams if you like under that category. You are welcome to for the low cost of 300 Rand for your initial registration. So yes, you enter once and you can send as many teams to the registration as you like. This is specific for in-house and the in-house competition, which is not yet up on our website because we are still in the process of developing a little bit of it. If you found this webinar very useful, you will find the others hopefully even more useful as we cover more in-depth information on the various categories, as well as judging. If you are new to the WRO, we strongly suggest that you come and join us and judge at a competition. You do not need to have any prior experience. The only thing you need to know is the rules for the category in which you are judging. Our next webinar will be on the 20th of March, and this will all be about team registration, important venues and dates, things that you need to register, as well as the costs and the payments. We have updated and changed our registration system, so it is something new, something special. It has been working very well so far, and if you run into any issues with the registration, you just need to email wro@handsontech.co.za. Thank you, everybody. We are going to just end the webinar there. Thank you for attending. If you want to attend more webinars, jump onto our website, WROSA.co.za, and you will find our webinars under the resource panel where you can register for more. Thank you, everybody. Have a great evening, and we wish you the best of luck for your preparations for WRO 2024.